So I've been looking at some questions from the Georg Mohr maths competition, 2006, round one. I'm going to look at question 11 in this video. So it says the numbers a, b, c, and d satisfy the equations a plus b minus c equals d. And then it says the symbol, that symbol means and. So and a minus b plus c equals d, and minus a plus b minus c equals d, and minus a minus b plus c equals d. So it's essentially some simultaneous equations in four different variables. And then it asks you which of the following you can deduce from the above information. So I'm going to look at these simultaneous equations on my paper here. I've written them out already. And I'm going to try and eliminate some variables. So I've called the equations 1, 2, 3, and 4. And then I noticed that, they've all got A's, B's, and C's, but some have got plus and minus the same thing. So, for example, if I take equation 1 and equation 2 and add them together, that gives me 2a. 2a's there. Then the b's and the c's, they're all plus and minus in their respective equations, so they cancel each other out. And then when I add the d's, I get 2d. So 2a equals 2d, therefore a is equal to d. So actually, having done that, a equals d, that's something I can deduce from the whole thing. And then perhaps I can replace all of the d's with a's to help me simplify the whole system. So I'll replace all of the d's with a's. And then some of these have got a's and b's the same side. So for example, equation 1 has got an a on both sides. So I can take away the a's from both sides and get, let me just write it underneath. If I take away, let's just eliminate that thing. Okay, so if I take equation 1 there and take away an a from both sides, I get b minus c equals 0. Add c to both sides, b equals c. So that's another interesting thing. B equals c. So I can kind of reduce the whole system to something with just two equations, or four equations in two unknowns, I mean. So in fact, I think I'm going to just go through and replace all of the c's with b's, since I've established that they're equal. Let's take that lot, delete, and replace them all with b's. And then what have I got now? So I've got b minus b, they disappear. Minus b plus b, they disappear. Yep. Oh, and now I'm left with some equations that say a equals a, but I'm also left with some equations that say a equals minus a. So that can only be true if a is 0. So in fact, a equals d, a equals d, and they're both equal to 0. So this is getting interesting. And then can I deduce anything further about the b's and the c's, I wonder? Let's have a look at what the question paper says now. So what can be deduced from this? The symbol, something means and. So a equals b and d equals 0. Well, I'm saying a equals d and b equals c. So let's focus on the ones that agree with that. So I'm saying a equals d. So I'm agreeing with that. I'm not agreeing with A equals B or B equals D. I am agreeing with B equals C, and I'm not agreeing with A equals C. So it looks like it's going to be that I can deduce B equals C and A equals 0. That's the one that agrees with everything I've done so far. So I'm going for answer B. I can deduce that B equals C and A is equal to 0.